Hey everyone, welcome to my 1.7 notes for you guys. What we're going to be talking about today is absolute value graphs, and what I'm going to do is show you what the original absolute value graph looks like here. You'll notice that this function is just the absolute value of x, that's it. Then what we're going to do is talk about how these transformations change the graph. If you look down just a little bit, you'll notice that some of these have other numbers like +1, -2, -3, -2, and I'm going to tell you what those do to this original graph. But this is called the parent function because this is where all the other graphs come from. So you can recreate this graph on your own if you want to. All you have to do is the absolute value of the x value. That's what this is telling you to do. Well, the absolute value of 2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. So basically, if they were negative, it changes them into a positive. The reason why that helps is because now we can go put these 5 points on my graph. So -2, 2, where x is -2, and this f parentheses x is the same thing as y. Whenever we talk about functions, that's when we're going to use this f of x. It and y are the same thing. We're going to be geared more towards the f of x style this year, though. We're going to be done with y equals for a little while. So I'm going to go to the point where x is -2 and y is 2. That's left 2 up 2. -1, 1 is left 1 up 1. 0, 0 is the origin right here in the middle. 1, 1, and 2, 2. So I'm just taking the points that I just found on my table and putting them on my graph. And technically you could plug in any numbers for x you wanted to. -2 to 2 is just the middle of our graph, so then we know it's going to be somewhere around here. And then you'll notice this kind of looks like a V. And it is a V-shaped graph, which is easy to remember because value starts with V. So an absolute value graph makes a V shape. And then this part down here might be a little bit newer to you. Basically, domain is the x values of your graph. And as you list all the possible x values of your graph, think of this like interval notation. You're going to go from left to right. Whereas range is going to be the y values, which are going to go from the bottom to the top. So for domain, the furthest to the left this graph can go is right here, but there's an arrow. You'll notice that these x values are negative. That's negative infinity. We already know that if you go to the left forever on a number line, you're going to negative infinity, and if you go to the right forever, you go to positive infinity. We also know that when we write infinities, we need to use parentheses. For range, now we care about this number line. So sometimes the x one is a little bit easier because we're used to a number line that goes like this. Now we're using this sideways number line and looking at the lowest and the highest that it can go. So the bottom of this graph is right here where the y value is 0. Now, here's the slight trick with this. Is that an open or a closed circle? Closed. We always draw closed circles when we're doing graphs other than inequalities, so it gets a bracket. Just like closed circles got one with our inequalities. Then, how high does this graph go? Well, these arrows technically mean that it's still going up and still going up. So it's going up forever to infinity. To infinity and beyond. Now let's talk transformations. You'll notice that some of these numbers are being added inside with x, and some of them are outside the absolute value. So when I say inside, I'm referring to inside the two absolute value bars, and when I say outside, I'm referring to anything that comes afterwards. Your graph is going to move left if you have a plus inside the two absolute value bars. And it's going to go right if you have a minus inside the absolute value bars. So for example, this one has a plus inside, so that means it's going to go left 1. This one has a minus, so it's going to go right 2. Now, you might be asking, left 1 from where, Mrs. McFadden? From the graph we just drew. So all of these points are going to move to the left 1. The easiest way to do this is to use this middle point right here, because it's the vertex. And just like the vertex of a shape that you learned about in geometry, it's sort of like the corner piece here. So if I take this piece and I move it to the left 1, now I'm at negative 1, right here. And then the rest of the points just follow. You'll notice that this side of the graph has a slope of 1, up 1 over 1, up 1 over 1. So I can copy that down over here. I just kind of kept it going. But to the left, it has a slope of negative 1, up 1, left 1, up 1, left 1. Okay, and then we just connect our dots. And that's how you use transformations to graph. You just take every single one of these points and move them left 1. Now let's talk domain and range. So the domain of this graph is left to right. You'll notice that again, this v goes left forever and right forever. That means negative infinity to infinity again. And you'll get kind of the trend of that. It happens a lot because these are all going to go left to right forever. That's what the v's do. But the range, guess what? Even though we moved it to the left, that didn't affect how high or low the graph went. So the range is still 0 to infinity. And then I'm going to go ahead and do this one too. What would happen if I take that point that's originally right here in the middle, like that vertex I was talking to you about that starts at 0, 0, and I moved it right 2? Now it's here. But I still have the same pattern on each side. So it's still going to go up 1, right 1. And it's still going to go up 1, left 1. And again, I haven't affected the range at all because I didn't move it up or down. And even though I'm moving it left to right, that only changes the x values, or the domain. Range is y, and we haven't gone up or down. You can't change infinity. It's still negative infinity to infinity. It just happens to look like the center is over here instead. Forever is the same thing as forever plus 2. Now let's talk about the vertical ones. So for the vertical transformations, up is if you have a plus on the outside, and down is if you have a minus on the outside. So for this one, since I have a minus 3 on the inside, that's right, 3. And since I have a minus 2 on the outside, that's down 2. So now from my middle point where it was, I need to go right 3 down 2 to find my new middle point. And then from there, my graph goes just like this, up 1, right 1, and up 1, left 1. So as long as you follow the slope of this original v, you should be able to graph a new one. You're just changing where this middle point goes. And let's do the domain and range of this one really quick. So that domain, even though it moved right 3, is still infinity to infinity. The range has moved down 2. So instead of starting at 0, the lowest point is now at negative 2. So we have -2 to infinity. And then there's one last transformation we haven't filled in yet, and that is the stretch and shrink. These change the shape of your graph. So instead of having a V that's this wide, you can make a V that's, say, this wide. And that's going to change the slope. So if there's a number in front of the absolute value, it's going to become the slope. But it's not just any slope, it's the slope on the right side. Then we have a vertical reflection. What that means is that the graph is going to turn upside down like this instead of right side up like this. This only happens if the number in front is negative. Let's go talk about how that affects the graph. So for this one, you'll notice that I don't have any pluses and minuses over here. So this is just going to change the shape of my graph. And the slope is going to be -2 on the right side. So we're still going to start here in the middle because we're not shifting left or right, up or down. But instead of going up 1 over 1 like this, like it did before, my new slope over there is -2 or -2 over 1. So I'm going to go down to right 1. And the reason why I said that's only the slope on the right side is because we just need to make the left side match. So since this went down to right 1, I'm going to go down to left 1 to make the other side symmetrically match. And you'll notice it's still going left and right forever, it's just upside down. So my domain is -infinity to infinity, left to right forever. The range, which is bottom to top, goes down forever. That's -infinity on the y-axis. And the top part is 0. So it's kind of like the original range, but backwards. Let's do the same thing over here. Now my slope is going to be 3. Still starting in the middle because I don't see any pluses or minuses. And it's going to go up 3 over 1. Like that. Or up 3 left 1. Notice how this makes a really skinny V shape? That is called a vertical stretch. This one over here is also a vertical stretch, but it is also a reflection since it went upside down too. The reason why these two are stretching is because that's a whole number slope. Over here, when this is a fraction slope, it's going to be called a vertical shrink. And these two are stretches because it's like you took the two ends of the graph and stretched them up. This one is going to do this vertical shrink, and this means that we're going down 3 because it's a minus on the outside. And a minus on the outside moves the graph down. So the graph starts at -3, and then it has a slope of 2/3. Up 2, right 3, up 2, right 3. Or up 2, left 3, up 2, left 3. So now you'll notice that this V looks much wider and flatter. It's as if you'd taken the ends of the graph and shoved them together or shrunk them down. But you'll notice the left and the right aren't changing. They're still going to the left forever and to the right forever. And then the range is the y values. This one starts at 0 and goes up to infinity. This one starts at -3 and goes up to infinity. Here's the neat thing about the graphs. You can actually use them to solve equations. Here's how. Let me get my lights to turn back on. There they go. This means a minus on the inside is right. Okay, so this is going to go right to a plus on the outside, up. So right to up 1. And there's no number in front over here, right? So we're going to do our regular slope. I'm just moving up 1 and over 1. Here's how you use this to solve an equation. It equals 5. So you're going to draw a line where y equals 5. And you want to pick these 2 points where they cross. We're looking for the x values. We already know we want y to be 5. The x values are going to be -2 and 6. Over here, a plus on the inside is left 3. A minus on the outside is down 4. Left 3, down 4, got it. Then it has a slope of 2. So you're going to go up 2 over 1 to the right. And then you're going to go up 2 over 1 to the left. And draw that V. This one wants to know where it is greater than 0. So here's 0. The graph is above y equals 0 here and here. We don't want this part because that's where it's below the line. Greater than means above. So we've got everything over here from -infinity to -5. And then from -1 to positive infinity. So we're basically treating this like our number line. And I'm going to put everything in parentheses because I don't want it to be equals to, I just want it to be greater than. And lastly, over here, minus on the inside is right, minus on the outside is down. So right 1, down 3. And there's no number in front, so it's going to have just your up 1, right 1, and up 1, left 1. So you're basically just recreating that V from that middle point. And we want to find out where it is. I'm going to keep drawing my points to help you out a little bit. Less than or equal to 1. Well, here's where y equals 1. This graph is less than or equal to that from here to here. So from -3 all the way to 5. And since this one is or equals to, you use the brackets. So you can solve inequalities with absolute values by looking at whether their graph is above for greater than or below for less than.